Oh god, it's been too long. Just dusting the cobwebs off of my Streamlabs because it's been way too long since I've last done an OpenGL stream. It's felt like a lot forever, but it has only been 1.5 weeks. But we are back in it. And today, as you can tell by the title, we are going to be looking at some new rendering concepts. And specifically, we're going to be looking at how to render an alternative method to render multiple of the same object. So let's just go right. Let's just look at what we have, or what we had from last video. We created our little model array, and if you pressed F, it would fire something, and it would just absolutely just launch it. Oh, that's kind of loud. Oh shit, that's not good. I don't know what that is, whatever. Anyway, the first thing I wanted to change was just the, I don't know what it's called, the frickin', oh, what's up, Nancy? Yeah, it's been a little bit. The first thing I wanted to change was, this stuff over here where we actually gave the energy, or applied the impulse rather. I'm just going to change this to a transfer energy. So rb.transfer energy. Did we write? Yeah, we wrote that method. Oh, and then I also wanted to. You can tell it's been a while. Let me just. So in rigid body, when we say transfer energy, it's not really going to be. Even though energy is a scalar, we do have to add a direction because that energy is coming from some force which has a direction. So we're just going to specify a direction with a 3D vector. And then in rigidbody.cpp, the only thing we have to change is what do we have to change? Let me just make sure I'm doing this right. Okay. The only thing we have to change here is just make delta v a 3D vector, and then at the end multiply this result by direction, and then make sure to add that parameter up top here. So now when we transfer, let's say 100 joules in the camera default camera.camera front, it's going to be more consistent, and the reason is when we did apply impulse, we were passing in a dt, and that dt varies for pretty much every iteration. So as a result, we had that varying, like, exit velocity. So now it's just going to be the same thing every time, because you're only transferring a certain amount of energy, and it's not dependent on time. It's a constant amount of energy. Okay, so let's actually get into the stuff I wanted to do. So as of now, if we look in our model array class, which we did last time, we use this class to store multiple instances of an object that have the same vertex data, so the same VBO data, and all that stuff. And in each iteration, each render, we called model.render for each of those things. And it turns out that this is actually taxing, especially on the CPU, because every time we communicate with the CPU, between the CPU and the GPU, there's an extra there's an extra amount of time attributed with that, because you have to initiate communication, you have to initiate the pipeline, and so on and so forth. And the way to make this more efficient is if you pass in the positions and sizes of each instance to the GPU at the time that you initiate communications, it will be less taxing to both the CPU and the GPU. So we're essentially going to be putting more work on the GPU, and that's okay, because the GPU has thousands of what are called CUDA cores, and these are the things that perform the GLSL compilation or the shader program. So and they sometimes have thousands of them. So if we just pass in some extra data all at once, the GPU will know what to do with it. And this is actually called instancing. And the reason why is because we are passing several instances of an object, different positions, offsets, sizes, basically in a vertex buffer. So we're going to look at how to do that, and it should be pretty interesting to do. All right, so let's go into our model array class, and in the class we're going to have to add a couple of things here. We're going to have to add something to store all the vertices, all of the positions, or not the vertices, but only the positions and sizes, and then we'll also need a vertex buffer object for each of those. So we're going to make all of these protected for now. Just turns the I muted it. Jesus Christ, that's loud. So our VBOs, we're going to have unsigned int position VBO, unsigned int size VBO, and then we're going to have a list of 3D vectors for the positions and sizes. So standard vector GLM vec3 positions and standard vector of GLM vec3 sizes. All right, so now let's go into the init method, and there is one thing that we do have to do that we forgot to do in the last video. Is each of these instance objects, so the lamp and the sphere, anything that extends from model array, we do want to make this call the base class. So we don't want to say model init, we want to say model array init. This is just because we do want to call this extra code when we initialize these objects. We don't just want to initialize the actual meshes of the object, rather we want to initialize the object with the extra of VBOs now. So in sphere array and in lamp array, we want to call model array init rather than the model.init. All right, now let's actually start writing some of this stuff. So in model.init, in model array.init, we're first going to initialize the object. So we're going to get all the vertices from a simp or whatever you're getting it from, and then we're going to start with our VBOs. So at this point, the VAO is generated from each mesh. So we just have to generate each VBO, or the 2 new VBOs just here, and then we'll attach them for each mesh, just like you would do with async or whatever other way you pass in vertices. So we are going to generate positions VBO. So GLGenBuffers1, and then a reference to pose VBO, and then GLBindBuffer, GLArrayBuffer, and then we're going to set a how do I want to do this? No, let's just dive into the deep end. So we're essentially going to have a cap on this, because with the spheres we add on to it. It's a dynamic list, but with the lamps it's static. So we're just going to make a dynamic list. So we're going to have an upper bound, and I'll define that as, so define upper, oh, I left my water down. So I'm going to define upper bound as 100. And then in GLBindBuffer, there are a couple of things that we can do here. It's essentially just allocating data for the VBO. And then if we actually specify data to pass in, it's going to then put that data in that location. But if we pass in a null, it's just going to allocate that data and not put anything in there. So that'll be a dynamically stored, or then we can put stuff in during the render. So the way we're going to do that is in GLBindBuffer, we're going to specify a size. So upper bound times, and then we're going to do the size of a GLM vec3, so 3 times size of float. And then, like I said, we're going to pass in a null for the data, because we don't want to store any data. And then now we're actually going to, instead of doing static draw, we are going to do GL dynamic draw. And we looked at what each of these do a while back. It's been a long time. But essentially, instead of doing static draw, we're passing in dynamic draw, which means that the graphics card will store this data in a more readily accessible area, because it's going to be changed every render in our case here. And I did forget something. We have to bind the buffer. Oh, I just completely skipped that. So that this was actually the method GLBufferData, and then above that we need to bind the buffer. So GLBindBuffer, and then just GLArrayBuffer, and then pose VBO, and then we can just bind a buffer 0 after that. So GLBindBuffer, ArrayBuffer, and then 0. And then we're going to pretty much do the same thing with the size VBO. So generate size VBO. So GLGenBuffers 1, and then a reference to the size VBO. And then we're going to bind the buffer. So OpenGL knows that we're setting the data for this buffer. Size VBO. And then we're essentially going to actually use the same exact line here. Yeah, it is the same exact line. So you can actually just copy and paste that. And I misspelled that. And then we're just going to bind a 0. So no VBOs are bound. All right. Now we're actually going to be setting our attribute pointers. So with each mesh in a simp, what's going on with the music? It's on shuffle. God damn it. All right, whatever. So in a simp, what happens is we generate each VBO for each mesh independently, and we have to do that because each. Oh God, all right, I need to put this on shuffle. There we go. That's all right. And the reason why is because each mesh has different vertex data. It's going to have different positions and different this and that, different normals. But here, we're just generating a single VBO or 2 VBOs for the entire model, for each mesh, because it's going to be static for each mesh. This is the position and the size of the whole object, not just of that certain mesh. So now what we're going to do is we're going to set attribute pointers for each mesh. So we're essentially just going to iterate through the meshes. So for unsigned int I is equal to 0, the size or the number of meshes is equal to model.meshes.size. And the reason why IntelliSense is shitting itself is because this is a template, so it doesn't know what model actually is. And then we're going to do I is less than size, I++. All right. So pretty much the same thing what we do in mesh.cpp. We actually have to make the VAO public in mesh if it's not already. Oh, it is. Okay, so we're all good. So same procedure. So GL bind vertex array model.meshes at I. So just getting the ith mesh, and then .vao, and then the positions. So GL bind buffer, GL array buffer, and then pose VBO. Now this next line is going to be a little weird because so far in each mesh we already have, let's see, we already have a vertex or a position, normal, and text coordinate or texture coordinate. And this takes up 0, 1, and 2, those different positions in the shaders. So we're going to have to continue on after that with 3 and 4. So when we say GL vertex attrib pointer, we're going to pass in the index now 3 because we're starting at the 3rd index. So 3, and then the size is 3 because that's the number in each iteration. And then type is GL float. Don't normalize. And 3 times size of float. And the reason why we can do this is because we have different VBOs for each the positions and sizes. Now if we combine the two, we would have to do a 6 times the size of float to get to the next element. But we're just going to keep it at 3 right now and just keep them separate. And then the offset will be just a void star to 0. And then GL enable vertex attrib array 3. And then next is the sizes. So GL bind buffer, GLArray_buffer, and then we're going to say size VBO now. And then pretty much the same thing, except we're going to use index 4 now. So GLVertexAttrib pointer 4 for the 4th index, and then everything else is the same. So 3 GLFloat GLFalse 3 times size of float, because that's still the size of the stride, and then a offset of 0. And then GLEnable vertex attribute array 4. That worked, yeah. All right. Now we do our next thing where we just bind GLBind buffer to clear the buffer, GLArray buffer 0. Now we can't just do this without stating anything else. Oh, we're already blowing our load with Sweeting, son of a bitch. It's already playing the best song, but what? It's okay. So if we just left this, if we just left it like this, what OpenGL would do would be that it would just take, or it would, for each vertex, it would get the next position or the next size, which is what it does in mesh.cpp. For every iteration, or for every vertex, it gets a new vertex position, new vertex normal, and new vertex texture coordinate. But we actually want it to get it on every instance of drawing, not every vertex. So we're going to say OpenGL, draw this entire object, and then get the next model position and get the next model size. So the way we're going to do that is we're going to say GLVertexAttrib divisor, and then we're going to say the specified index, so it's 3, and then we're going to reset it every 1 instance. So I'll just say that out here. So reset 3rd attribute every 1 instance, and then we're going to do the same thing for the 4th attribute. So GLVertexAttrib divisor, and then 4 and 1, and then this is just reset 4th attribute every 1 instance, and then we're going to bind our we're going to clear the vertex array. So GLBind vertex array 0. All right. Pretty good, yeah. All right, so now we can actually go into the rendering. So just delete everything that we have in render, because we're going to be revamping the whole thing. So we're actually going to, what do I want to do? Oh yeah, okay. So if you remember, or you know what, I'm actually going to just leave that there for now. When we did the lamps, we actually overrode the render method because it had a special way to get the position of each rigid body. So we're essentially going to, instead of overriding the entire method and just rewriting a lot of the same code, we're going to pass in a parameter that tells this model array, oh, I want you to reset the lists, or I don't want you. So it's going to be an extra parameter, and it's going to be a boolean. So bool set lists is equal to true by default. And the reason why is because, once again, when we have dynamic data, we do want to be resetting the data every frame, because with the launch objects, they're falling, or they're moving because they have velocity. So just now you can delete the body of the render method, and let's start. So if set lists, we're gonna clear the lists first. So positions.clear and sizes.clear, and then we're gonna now iterate through the instances. So for rigid body, and then remember we want to do a reference to RB. So when we update it, it actually remembers that update. And then instances, we're going to say rb.update dt, and then we're just going to push back the data. So positions.pushback rb.pose, and then sizes.pushback model.size. Now this is just, the sizes stuff is just there because we haven't integrated size into the rigid body yet, and I think it's okay for now. Next, we just want to set just an optimization here. We're going to set the model matrix just so we don't have to tell OpenGL to do any dumb calculations, because we're going to be doing those calculations in the GPU since we're passing the translations and scaling into the VBO, so the CPU doesn't have to do it. Rather, the CUDA cores can do it the CUDA cores have to do it, and they can do it much faster. So we're going to say shader.set mat4 model, and then we're just going to pass in the son of a bitch, the identity matrix. So glm mat4 1.0f. All right. Now we're going to go ahead and call the render method for model because we still want it to prepare all the textures and whatever. So model.render shader dt. Did we pass in d? Yeah, we do. And then false, right? Yeah, for set. Let me just make sure. Yeah, set model is okay. Yeah, we don't want it to set the model because that's what we're doing. All right. Next thing that we want to do is we are going to add an extra parameter to model render because we're going to be using a special OpenGL method to actually render the objects in an instanced manner. So we're going to pass in another parameter to model.render, and it's going to be bool do render, and this is going to be set to true by default. And then in model.cpp, I just add that extra one there, so bool do render. And then at the bottom, we just want to say yeah, okay. Oh, and we also want to pass that over to the mesh. Yeah, because the mesh is actually the thing that's doing the texture loading and all that. So in mesh.render, we also want to say bool do render, and that's equal to true by default. And then now in mesh.cpp, we can go up to render, add that extra variable in, so bool do render, and then at the bottom, I don't know why that's there. We're going to say if do render. We're just going to render this stuff, and then we can also move this active texture into there. Okay. Yeah. Okay. So this just tells the program, oh, if I pass in false, don't actually render it because I'm going to render it in a different manner, which we will. And then we also have to pass that parameter in with model, so just pass in do render. All right. I'm going to get some water because I forgot. I'll be right back. What the fuck? Hope your Tuesdays, right? Yeah, hope your Tuesdays are going pretty well. I think yesterday was Memorial Day. It was, right? Yeah, I have lost sense of time, and I've said that in every freaking video, but it's true. All right. Let's keep going. So after we've passed in the we actually now need to pass this do render as false in model array because we don't want it to set the model or render the actual stuff. So it's going to have two falses in there. All right. Let me just refine to my place. All right. Now we're going to get into the meat and potatoes, the actual, the good stuff of this, of this new enlightening method of rendering shapes on the screen. So we're going to now be updating the data in each render. So in model array, we're going to say if positions.size does not equal 0. So this means that if there is a position to render, so if positions exist, so if essentially if instances exist rather, we're going to say GL bind buffer, GL array buffer, pose VBO. So pretty much what we have up here, but rather than doing GLBufferData, there's a slightly faster method called GLBufferSubData that only sets a certain sub-region of data. And the reason why we can do this is because, remember, we have an upper bound of 100 3D vectors, 100 times 3 times size of float. So we have that amount of space to allocate. And as a result, we're going to have to set up a cap on this. Or we already have the cap, but we're going to have to determine the new size or the new number of positions to actually render. So we're going to say int size is equal to the minimum, so standard min, between 100 or upper bound and in the integer of positions.size. So this just says if more than 100 instances only render 100, because that's the amount of data that we actually allocated. So if you go over, you're going to get some wacky shit. All right. So let's actually call this method. So GLBufferSubData, GL array buffer. The offset is 0. The size is going to be the size variable that we have. So size times 3 times size of float. And then the pointer to the first thing is going to be exactly what we have in mesh.cpp, which is just a pointer to the first object in the vector. So, or a reference rather. So a reference to positions at 0, where positions is that vector where we set all the positions. And we're going to do the exact same thing for the size VBO. So GL bind buffer, GL array buffer size VBO, GL buffer subdata, GL array buffer 0 size times 3 times size of float. And we're just assuming that they're the same exact size because I mean they are, because we only added for each instance, but we may change that in the future, but for now that's just what we're leaving it as. And then we're going to do the reference to the first object, so and sizes at 0. And then we're just going to clear the VBO. So at the end just say GL bind buffer, GL array buffer, and then 0. All right. So now that we've actually updated the data, so update, we're actually going to render it. So render instanced data. I'm going to use some cool terms. So what we're going to do here is we're essentially going to render through each mesh, or iterate through each mesh and just render it. So, but we are going to use a new method. So for unsigned int I is equal to 0, length is equal to model.meshes.size, I is less than length, and then I++. And we actually want to take this size variable and bring it outside because we are going to need it in here. So take that size and put it outside of the if statement there. So we're going to pretty much set it up the same way. So GL bind vertex array model.meshes at I .VAO. And this is just the VAO of the we're essentially just following the same model that we have up here, just the VAO draw and then clear the VAO. So I'll leave that empty for now, and then at the end we're going to say GL bind vertex array 0. Now this new method remember it's going to be it's going to be rendering stuff instance, and I think I explained a little bit of it, but instance truly means just rendering multiple instances of something with the same vertex data, or with the same summoning data. It makes it a lot more efficient, and you only have to call the GPU once, which is really good here, or rather once for each mesh. So the way we're going to do this is GL draw elements instanced, and it's the same thing as GL draw elements, except we have an extra variable at the end that specifies the number of instances. So we're going to say GL triangles model.meshes at i.indices.size, GL unsigned int, and then 0 for the offset. It's pretty much the exact same. It's that, but at the end we now need to specify the count, which is going to be size. Remember, where size is the minimum between 100 and, or the upper bound and positions, and the number of instances. All right, now we could be done, but we're not, because we set this data, but we haven't told the GPU how to process it. So we now need to create a new vertex shader. So in assets, go ahead and create a new folder. Can I do that? Yeah, new folder. And we're going to call it instance. And let's go ahead and now create a new file, just like we have for, you can honestly just copy and paste the object.vs file. You know, we're going to do that just because it's easier, because a lot of this stuff is pretty much the same. So rename it to instance.vs so we can distinguish. So instance.vs, and now in instance.vs we're going to add a couple of things. So first thing is we need to add our layout variables. So layout, now we have two extra ones, and they're in, remember, the third and fourth indices of the pointer, of the attribute pointer. So we're going to say layout location is equal to 3 in vec3 a offset. Layout location is equal to 4 in vec3 a size, and I'm just calling it offset because that's pretty much what it is. All right, now we are going to have a little, it's going to be a little different, the calculations here, because we have to actually translate it and size it. And this is because, remember, when we in the model array, we only just pass in the identity matrix to the model. So what we have to do now is calculate the position as if we translated it and scaled it. And that's relatively easy. The only thing that we have to do is just multiply each element by the size, and then just add the offset at the end. So we're going to say vec3 position is equal to vec3, and we're going to multiply each element of a pose times each element of a size. So we're going to do this individually, because I believe that you can't just multiply the two, because that's the dot product, if I'm right. You know, we'll test it both ways, but I know this works. So a pose.x times a size.x, and then a pose.y, etc., etc., etc. A size.y, a pose.z times a size.z. All right. Now in frag pose, when we calculate that, we just want to make this, the a pose, change it into pose plus a offset, and then we should be pretty good, right? I'm just making sure that I'm not missing anything. All right, so let's go into main.cpp. Let's actually try this shit out. All right. So we have a new vertex shader, so we need to create a new shader object for it. So we're going to say shader launch shader, because this is going to apply to only the oh, do I need to change, what do I need to do? Let me make sure I know what I'm doing here. We need to change two things here. So we're going to create a new shader for the launch objects, because it's going to have a new fragment shader, or a new vertex and fragment shader. Or no, the launch object is only going to have a new vertex shader, and so is the light shader. So we can make this, the lamp shader, make it assets for the vertex shader. Wait, for the lamp shader, we're going to change the vertex shader path to assets/instanced/ instanced.vs. That's what we have. And then for the launch shader, we're going to have the same thing, except for the fragment shader, we're just going to use the already existing. We're going to have the existing fragment shader, so assets/objects.fs. And then I think we're good, actually. Hold on, let me just. Is there anything else I have to do? Because we already set the. Oh, yeah, we need to. Because, yeah. I just said this in the beginning, but we need to change the way that we set the data for the lamps. So remember how we override the render method. We don't want to do that now, because we don't want to have to rewrite all the code that we did in model array.render. So all we're going to do is we're going to set the lists independently, and then we're going to pass in false for model array set lists. So we can actually just copy everything in the if set lists block and model array.render. Just copy that. Let me just make sure I'm doing this right. Hold on. Yeah, okay. So go into lamp.hpp and paste that code in there, and then just change the rigid body to point light, because once again we're not setting rigid bodies for the lights. And then just make this in light instances. Get rid of the update, and then we're going to say positions.pushback instead of rb.pose. We're going to say pl.position. Right? Yeah. And then we're going to call it superclass, because we do want to call all that other code. So we're going to say model array rather, render, and shader, dt, and then false, because we don't want it to set the lists. All right, now let's. I think that's it. I hope that's it. If this messes up, I'm gonna be kind of angry. Oh, great, errors. Oh yeah, then we do have to do something. So in model.h, make the mesh vertex public. So just that standard vector of mesh, just make that public so we can actually access it. All right, now let's run it. Oh, great. Lamp render does not take 4. Oh, yeah. We need to update the stupid shit in here because we... Yeah, okay. So in lamp, just say in the lamp render, just add the two parameters set model and do render. So bool set model is equal to true, and then bool do render is equal to true, just so we can pass these on to the model class, or the cube class rather. So set model and do render. And what we can actually do is in the cube class, we can get rid of our overriding of it because it does nothing actually, it just calls model render. So just delete that there, and then this should be all good. All right, now let's run it. Haha. Object.fs, yeah. Yeah, make sure that shader compiles properly. Okay, now we should be all good. Alright, oh, I hit the escape button. God damn it. Okay, now let's try it. So we have the lamps are rendering properly, which is beautiful, which means that the algorithm works. I mean, of course it works. And now let's try firing an object. So F. What? What the fuck? Oh, I'm an idiot because I don't even give it the new shader to render yet. Yeah, don't leave it to me. Okay. We need to say launch objects.render and pass in launch shader. And that would be the problem, is it if we did not update or add these extra layout variables, because if it just got zeros for those, then it would just initialize or render it at the initial position. So, which is 0, 0, 0. As if offset was 0 and size is 1. So now let's try this. Okay. Nice. And let's... What happened? Oh, this is kind of bungling. Oh, I don't activate. Do I activate? Hold on. What am I missing? What am I missing? Oh, I don't even set the stupid God fucking damn it. Okay. We need to add a couple things, just 2 lines of code here. When we go to render the objects, we just want to say launch shader dot set map 4, and then we're going to say view, and then launch shader dot set map 4 projection. That was just stupid. I forgot that. All right, now let's try it. Third attempt. It's fourth, I think. Okay. What? Oh god, there's something. What the heck is up? I'm setting all the stupid shit. Oh, this isn't gonna be one of those errors where you just can't figure it out. Hold on. This is gonna take a lot, man. It's gonna be 1 line of code that I forgot to add in. Oh, did I? All right, we're using the proper instance/instance.vs. Yeah, this looks proper. Yeah. Set GL position. Yeah. This is confusing. I mean, I'm pretty much doing the exact same thing that I would do for any other model, right? I mean, let me... It looks like it's trying to... It's not changing the position, so it has to be a problem with the instancing then. But we blasted through that. What the hell? What the hell? What? I'm honestly confused. What the fuck? Alright, let's make sure that this is actually called. Because if it isn't, then there's something wrong. Alright, position size is 4, yeah. Yeah. Ooh, I think this is No, wait. No, that's... Size is 4, that's right, yeah. Render... God damn it. Let me try getting rid of this, but that shouldn't do anything. But I mean, it's... You know, it might be the rigid body. Yeah, because the lights are... No, it's passing in the data properly, because the lamps are at the different positions. So maybe sphere... No, we just call render and then pass in... I hope we pass in true, right? Yeah, we just leave it to the default, which is set list. So let me... Alright, let me just make sure that this is also getting called when we want it to. Okay, it is. Alright. Alright, so we have one instance, that's right. Yeah. Good. Does it have something to do with this? This is one of the worst dumb things that you could possibly... This is just an error that I'm never gonna freaking find. Everything looks right. Length is 1, or yeah, that's good. And then, oh, hold on. Size is 1, that's right. GL... Son of a bitch. You know what, why is this not working? It's not even far, it has to be something with this then. With the rigid body. But I mean, I'm passing in a reference, so I don't know what's... I actually have no clue what's wrong. You know, let me try, Alright, let me try this real quick. I'm just going to make sure that the position actually updates. Alright. Oh no, I'm getting the stupid lamps. Great. Let's just say, int z. There you go. Just so I can get a breakpoint. Oh, it never hit the... Why did it never hit the breakpoint? It's gonna hit this break. It hit... why? Yeah, okay, it's hitting the breakpoint. Alright, instances. Position is 0. Continue. Position is 0.23. Yeah. Wait, no. Oh, so it was gone. Alright, yeah, that makes sense. 0. Okay. Now, yeah, exactly. It's giving us it's updating the values. Alright, there's something stupid here. It has to be a naming error or something. because the positions are being updated, which is, and then we're resetting, I hope. The thing is, it's working with the freaking, it's working with the lamps, which is even weirder. Come on. Everything is working perfectly with the lamps. So what is the difference between the lamps? Alright, so the difference between the lamps and this is that they don't set the list, or lamp sets the list independently. So maybe, let me try overriding that. So void render. Let me just take this. That, get a little bit of the rigid body in there. Don't write any code yet. I'm just trying to make sure that this works. So don't set the list, or no. All right, now let's try it. Don't know why it would make it any better though. That's the weird thing. Ah, it didn't. Okay. Is it a problem with the shader? No, it's not. Because it's getting this properly. Oh, I hate this so much. When you just cannot find what the freaking problem is. I don't think staring at it that this is going to work properly, but you know, it could, but it's hitting all the right breakpoints. I know that much, because it, son of a bitch, just get out of there. Come on. Because it breaks right here when we tell it to set the list, which is right, and it has all the proper instances. The thing is, it's, you know, let me try not rendering the lamps at all. Let me just try that. Let me just not even initialize the lamps and see if that works. No, so it has to, alright, so it's not it's no like overlapping problem, it just has to be, oh, cause I didn't fucking activate the shader, that's, wait, but, did I? No, I didn't. I swear to God, if that's the problem, I'm actually going to shit my pants. Oh! Fucking. Okay, I don't know why that. Oh, because it was using the oh, that's why. Because it was using the silly ass active shader at the time, which was. Oh, I was just pressing my volume key. That's why that happened. By the way, just if you were wondering. But what? Oh, because, yeah, the reason why is because it was just using the active shader, which at the time was just default shader. But concern I do have is that it was just not colored at all. But you see that it still works, and no memory is, no memory loss, or memory suffering. And it's fast, and this will be faster, by the way, just FYI. That, like, if you start, like with instance rendering is used to render leaves, grass, blades of grass, stuff like that. So this does actually reduce a lot of time, because if you're calling model.render for each blade of grass, it's gonna freaking tax the machine crazily. Like there's examples with this in asteroids where it just reduces if you could only render like 100 asteroids using model.render, and then if you use render elements instance, you can make it like 10,000. It's just ridiculous time efficiency. Now my next concern is that it's black, which means it's not getting any color. And I'm gonna spoil it for you. I almost like hit my head on my desk like several times in debugging this, and the reason why is because we don't render the lighting in the stupid shader. So I'm just gonna spoil it for you, because this took me a whole like several hours to realize that I was being an idiot. So all you have to do is just activate the launch shader up top in the for loop, or in the render loop, and then we're just going to, everywhere where you set the lighting for the regular shader, just add the launch shader in there too. So you can pretty much just, on Visual Studio, what you can do is Control D, and that just copies the current line. So just do that and just add a launch in front of that. So that goes for the lamps. So, god damn it. This one too. Nope, not that. Oh, what just happened? Son of a bitch, I keep pressing Control F. Alright, please work. Please, I'm praying. It should, yeah. If this doesn't work, I'm actually going to be actually clueless. And voila, it works. If I got 100 in here, it would only render 100. No more, no less. And, you know, like the rule of 2. I can go full nerd on this, but, you know. Instead of the rule of 2 with the Sith, it's the rule of 100 with the instanced objects. Alright. Yes, that's pretty much the core code that I wanted to write today, but in preparation for the absolutely steaming content that I'm going to be doing on Thursday with something called a bounding box, I do want to create a model to do that, so we don't have to write as much code on Thursday, because there is going to be a lot of code there. And this is actually an application of instance rendering, where we can instance render boxes. Now I'm not talking about like cubes like we have, but rather lined boxes. And you might be wondering, oh, Michael, can't we just say in cube.hpp, can't we just say render with GL lines instead of GL triangles? Well, if you did that, I can actually show you what that would look like. GL lines. What's playing? All right. With the cubes, or with the cubes with the lights, it didn't even work. Oh, because because GL lines there. Oh, by the way, if you changed any code here, just delete that render in the sphere like that we overrode, because I was losing my mind. Alright, so let me show you what GL lines look with the cubes. I see. Oh, an incomplete cube. That's really cool, isn't it? No, it's not. It's honestly sucks, because, you know, it's just severely just actually disappointing to me, because if you want to do like, if you want to get the box around something, what's the top? What's the bound up here? Well, too bad you can't see it, because you know, it's fucking chump GL lines. It's not that fault, but you know, we're gonna create a separate model, because I also don't want to have to pass in another parameter saying render GL lines. That would just make things really complicated. So we're just going to create a whole new model altogether called a box. I know, so creative. And it's going to be actually a little bit of, it's going to be kind of annoying, but it'll make the stuff next time a lot more focused on the actual topic. And this is instance too. So let's go ahead and just clear the tabs here. And then in models, go ahead and create a new source file. I'm going to call this box.hpp. And we're not going to actually inherit from anything because, once again, we're doing GL lines this time. You know what, I might want to, but for now I think we're... You know, it actually is the same exact stupid code. Like, it actually just is. You know what, we're going to do it. Use... Fuck. Yeah, okay. So in model array, let's add a new parameter to render. And I don't know what is GL... Is that a GL... What is it? GL enum? Unsigned integer? I don't know what it is. We're just going to add a parameter called unsigned int render mode. And we're going to set that to GL triangles by default. And then in render instance, we're going to say render mode. So I'm just going to make sure everything works again. Yeah, alright, that's all good. Perfect. So just adding that extra parameter is going to give us the freedom to now do GL lines in our new class. So let's get started here. Our macros, so if not defined, box HPP, define box HPP, and if we're going to include model array.hpp, we're going to include /shader.h, and then everything else is there, I think. And now we're going to say class box, and that's going to can I actually do this from, I'm not sure. Yeah, we're good. Okay, don't worry. It's okay. So box inherits from model array. Alright, so we're going to have public stuff and private or protected. I'm just going to make it private. So, ooh, my dog. I'm going to go get my dog, 1 second. Doggy is here. We will now be much more productive. Oh, I missed the best part. Oh, goddamn. Alright, let's regain our ground. Okay. So instead of having our model, we're going to just create our own, like instead of using the model class, we're going to create our own model, VAO, all that good stuff, just because we're not going to have any normal, we're not going to have normal vectors or texture coordinates, because we're just going to be drawing lines, and it's just going to be there for demonstration purposes and you know, like debugging. It's not going to be actually there in the final product. So we're going to say unsigned int VAO, unsigned int VBO, and then unsigned, or you know, we can just put them all in the same line. So VBO and EBO. And then we're going to say, we're going to have standard vector of float for vertices and standard vector of unsigned int for indices. And the reason why is because we're going to be creating our own indices and vertices from a paste bin that I created. Just go ahead and take this stuff. The link is in the description of the video. So all I did here was I just created the vertices for a cube essentially, but I changed it so that we can use element buffer or EBOs now. So void init, just paste that stuff in there. And the reason why we can't use an EBO for the other cube model is because the normal vectors are not the same for each side. So let's say the bottom left corner or bottom left and back corner. So when all x, y, and z are all negative, that's going to have a couple of different normal vectors and a couple of different texture coordinates. So essentially, we're just going to we can't use EBOs then because, or we can, but it's going to be pointless because we're just going to render it each vertex in order. But now we can actually do it, and I just constructed these. You can look at the comments, and these are just the connecting each vertex. And I put them in pairs of 2 because when you render with GL lines, it actually just looks for wait, I hope this is gonna work. Oh, this isn't gonna work. You know what? Don't do the render mode. We're just gonna pass in another bool do render, and that's equal to true. Just because there's not gonna be any meshes here. You can go if you want. Here, let's turn you around this way, and you can go if you want. So in model array, just say down here if do render. Just what? Oh god, damn it! If do render, just do that. I'm winging this, by the way. Like I did it in a different way in practice, so it's not going to be perfect on the first try. So now you can actually just get rid of the render mode and just change render mode back to GL triangles. And the reason why we have to do render is because there are going to be no meshes in the box. It's just going to be the box has its own VAO, VBO, and all that stuff in there. Okay, so now let's just go through our regular process. So we're going to generate VAO. So GL bind vertex array. Go ahead, you can go. 1, and then a reference to the VAO. GL bind vertex array. VAO. Is that not going to work? What's wrong? I don't know what's wrong. Alright. And we're going to generate vertices VBO. So GL gen buffers. And then 1, and then a reference to the vertex VBO. And then GL bind buffer. GL array buffer. What song is this? Oh, this is a disc. I haven't heard this in a long ass time. Wait for the beat drop though. So GL bind buffer. We're gonna bind the VBO. There you go. See, beat drop. And then GL buffer. I'm sorry, this is super confusing because I'm going back and forth between my dog, the music, and the code. We're just following the same procedure that we have in the past. So if you're getting confused, just look back to that code. So GL buffer data, GL buffer data, GL array buffer, and we're now going to say for the size, vertices dot size times size of float, and then a reference to the first element of vertices at 0, and then GL static draw. And the reason why we're doing static draw and just a vertices dot size times size of float, not times 3, is because I just pair these up in 3. Make sure that's a public model array there. And this is just the vertex data. It's not going to change or anything. And then we want to clear the VBO. So GLBind buffer, GLArray buffer, and then 0. And then next, we want to do our EBO. So generate EBO. So GLGenBuffers 1, and then a reference to EBO. GLBind buffer, GLElementArray buffer. You can go. My dog seems like he wants to hop off my lap, but he's not. Alright, so GLElementArray buffer and then EBO. And we want to set the data, and once again this is going to be static because it's not changing. So GLBufferData, GLElementArray buffer, size of unsigned int, or indices.size times that. So indices.size times size of unsigned int, a reference to the first element, so indices at 0, and then GL static draw. Alright, and then after this, we want to clear the VAO, so call GLBind vertex array 0, and then we're going to generate the dynamic data, so generate dynamic VBOs with the model array, with the superclass. Why is it not working? Oh. Oh, we have to make this a model, so public model. Okay. And then we can create a box array. Yeah, okay, that works. So now, or can we? Let me make sure that this works properly. I don't. This is very confusing. I'm really sorry, because I'm confusing myself. Let's see. I'm hoping that this is all we have to write. Let me just check the mesh class to make sure that it is. Mesh, yeah, okay, it is. We're good. All right, so that's for init, and then for render, we can actually just look at cube to make sure that that's all we need. Oh, and then we need to do frickin'. Is this gonna work? You know what? We're not gonna extend from anything. This is gonna make it really confusing. It's gonna make it very confusing. So now that we haven't included from shader, we need to do a couple of things now. Or now that we haven't included from model. Why does it? God damn it all. Alright, I'm sorry. This is super confusing. We're going to go back to the code that I wrote initially because that's what worked. So we're going to do our includes. So include glad/glad.h and include glfw/glfw3.h, and then include glm/glm.hpp, and then include vector. And now we need to have our vectors for the vertices and indices, and we do. Okay. The reason why I'm confusing myself right now is because we can't use a model because we're not, once again, we're not going to have any normal vectors or texture coordinates, so the vertex list is going to be all messed up. So just to conserve memory, we're just going to do this right here. What is? My dog is wandering around and I don't know if I like it. You know, I'm going to go put him in bed. I'll be right back. think I need to take a breath because I'm just. Oh, God damn it. Impossible. Alright, you're staying here. No barking. Alright, I'm overcomplicating all this. I'm just gonna go. Oh, Jesus, son of a bitch. Stop it. What does he see? There's literally nothing to see. Okay. Let's regain our ground right now. Alright, since we are not inheriting from anything, we have to... Oh, God. Stop it. Now. I think he sees something, but what the hell can he see? He probably smells a skunk. Okay, so we have to do a couple more things now. 1 second. It's gonna be... You can't hear if the dog is barking. Stop your barking. Stop it. You're sitting with me now. Stop the barking. God damn. Okay. So now that we're doing everything in this class, we have to have our extra VBOs for the positions and offsets. So, or the offsets and sizes. So unsigned int, offset VBO, and size VBO. And then we also want to have a public list for the offsets and sizes. So in public, do a standard vector of GLM-vec3 offsets and standard vector of GLM-vec3 sizes. Alright. Now let's go ahead and actually put stuff in these VBOs here. And the way we're going to do that is just like, I kind of want to... You know, I'm actually just going to copy from model array because I'm too lazy to write this. So pretty much this stuff over here, when we generate the position and size VBO, just copy that and paste it under the generation of the vertices VBO, and change pose VBO to offset VBO. And then we actually have to define our upper bound, which is going to be 100. So define upper bound 100. Alright. So we've generated our VBOs. Now we need to, and once again, this is with dynamic draw because we're going to be updating the data. Okay, now we can become calm with this nice music. Okay. Now we're going to set our attribute pointers. So set attribute pointers. So we're going to start with the vertex positions. So GLBind buffer, GLArray buffer, VBO, GLVertex attrib pointer, 0, because this is the 0th index, 3, GLFloat, GLFalse, and then we're going to say 3 times the size of float, because once again, when we're passing in this as our VBO, it only has to go 3 floats to get to the next position. So 3 times size of float, and then a void star for 0. And then clear the vertex array. So GL enable vertex attribute array 0. And then we can actually take the other code from the model array right here where we set the attribute pointers for the position and size VBOs. So just copy that, paste it below there. So offsets and sizes, and then just rename pose VBO to offset VBO, and then we want to change these indices to 1, 1, and then 2, 2 there, because we don't want to do 1, 3, 4. We don't want to do 0, 3, 4. We want to do 1, 2, 3. And then we can also copy the GL vertex attribute divisors. Put those down there. So do the 1 and then replace it with a 1 and 2 or whatever index you made the offset and size. Alright, now that all the data is set, we can get into the rendering. It's just, Jesus, I don't know what the hell happened. We are, in the future, near future, we are going to have a long cleanup and organization episode where we just get rid of all this clutter, because there is just so much clutter here. It's ridiculous. Alright, let's you're not pooping on me, are you? No, he's not. Okay, we're all good. Alright, so void render shader, and then let's just go straight into it. We're going to set the model matrix. So shader dot set map for model, and then just our identity matrix, because once again we're not translating anything with the with our instances. We're going to be doing that in the shader itself. Then we want to update data. So this is going to be pretty much the same thing as model array. We can actually just copy and paste that entire thing here, except get rid of if do render, because we don't need that anymore. So copy from the rendering array or the rendering loop all the way up to where we calculate the size or the number of positions that we have to do. What do you smell? I'm convinced that you smell a skunk or something, because you're just up in arms. What the hell? All right, now we need to change a couple of names here. So standard min of upper bound and the integer of, no, do not move, you're staying right here. You're not gonna go ahead and start working again, Ollie. No, stay. So we're gonna say offsets dot size, because that's the new list that we're using for the offsets. Oh, we can also change this to just if size does not equal 0. There, and then we're gonna make this offset VBO, change pose VBO to offset VBO, and then just change the reference to the 0th element in the positions to the reference of the 0th element in the offsets list, like that. You can also change this to size does not equal 0, just so we don't have to calculate anymore. And then down where we render, we actually don't need to go through the for loop, because we only have one thing. We only have one, not really a mesh, but I'm going to call it a mesh to render. And then we just want to say bind the vertex array VAO instead of accessing some stupid mesh VAO. And then remove that model.meshes as well, so it should just become like that. And then change this to GL lines. And once again, lines now renders in pairs of indices. So when we pass in, when we say GL lines, it's going to render 0, 1, then 1, 2, 2, 3, 3, 0, etc., all the way, where I kind of labeled that out here. That would have been annoying to explain, but alright, so now that's all there, and then let's do our cleanup real quick. So void cleanup, we just want to say GL delete vertex arrays 1, a reference to VAO, GL delete vertex arrays 1 and vertices VBO. Wait, why do I say vertex arrays? Shouldn't it be vertex? It's not giving me anything either way, but shouldn't it be buffers for this one? Delete buffers. Yeah, I think it should. All and then GLDelete buffers 1, and then a reference to the offset VBO, and then GLDelete buffers 1, and then they reference the size VBO. Alright, this is something that's been pissing me off lately. Visual Studio is just IntelliSense just shitting itself. It's almost like some colorblind person is just sitting there like, you know, limp dick in hand, and it's just, well, I don't know what's going on here. You just gotta go ahead and right click the project and then click rescan solution, and it should give you all the errors now, which I'm not sure why it's giving me errors here. Oh, because I have that there, but why is this error still here? Oh, vertex arrays, right? Wait, no, that's not it. Oh, I mean, did I? Oh, this is GLGen vertex arrays. Yeah, okay. That line around 52 where we generate the VAO. I said GLBind vertex array. All right, now I believe we should be okay. Well, we haven't actually put anything in here, but we no, stay. You're staying here. You're not going to Bark. You're staying here. All right. So just recap. So just let me re-explain this because I did a shitty job of doing that while I was writing the code. We're essentially doing the same thing that we do with the mesh. We have our custom. Oh, what the hell? We have our custom vertex and other data. Why? We have a custom vertices data, custom indices data, which renders in pairs because we're doing lines. We generate our VAO, we generate the vertices VBO, which takes in static data from the vertices list. And then we do the same thing for the EBO. And then in between those, we generate the positions VBO and the offsets VBO. I keep saying that. The offset and the size VBO, and initialize it with an upper bound of 100 and then pass in null data so that it can dynamically change that data using GLBufferSubData in the render method. And then we set our attribute pointers, and then we tell OpenGL to reset the first and second attributes every instance. Quick note on attribute divisor, if you put 0 here, it would just behave normally. So if we said GLVertex attribute divisor 0,0, that would reset the VBO data every 0th instance, which is what it does. So that's how that would work. Alright, so let's actually try this out here. So we're going to need to create a couple of things here. We're going to need to create a new shader and then a new vertex, and with that new vertex and fragment shaders, we're going to need to create a object, and then we're going to need to render that object. So let's go ahead and at the top, my dog is just hugging my arm with his head. All right, I'm just going to leave that. All right, so we're going to say shader, box, shader, and we're going to initialize it with empty paths right now because we haven't actually done anything yet. So let's actually go and look at what that's going to look like. So box dot. All right. So for box.vs, it's pretty much going to look pretty similar to instance.vs. So I'm just going to go ahead and copy and paste. Oh god damn it. All right, whatever. We're just going to create a new file and then save it. Oh, not a new project. Alright, so text file, and then what we're going to say is version 330 core, and then we have 3 vertex attributes, so 3 layout variables. So layout location is equal to 0, in vec3a pose. Didn't we listen to this? Yeah, we did. Yeah, we listened to this. Oh, 15-minute song, that's what you love to see. So position of the vertex, and then we're gonna have our offset and size. Remember, we don't have any normal or texture coordinates here. So layout location is equal to 1, in vec3a offset, and then layout location is equal to 2, in vec3a size. and then we're going to take in our uniform variables. So uniform mat for model, uniform mat for view, and then uniform mat for projection. And then in main, we're just going to calculate the position and then put that in the calculations. So vec3 pose is equal to, we can actually just take that calculation from the instance.vs because it's the exact same. And then we're going to say GL underscore position is equal to projection times view times model times vec4 of position plus a offset 1.0. So this is pretty much what we have above in instance.vs, but we're just not calculating anything extra like the normal and texture coordinates because we don't need them. Where do you want to go? And notice how we're not actually outputting any other variables because we don't need normal or texture coordinates. Alright, yeah, you can jump off. Alright, I don't know what you're doing. Alright, so let's save this, and let's save it as box.vs for Vertex Shader and put it in the assets/instanced folder there. And then save it as in all files, save. And then refresh, include, and then let's go ahead and create our fragment shader, which is going to be relatively simple because I just want it to render as green, so it's not going to be anything fancy. So if you just copy in the lamp fragment shader, or I'll just go over it either way. So version 330 core, we output a fragment color. Don't take anything in, no uniform variables, nothing like that. And all we're going to say is frag color is equal to the 4D vector, and we're just going to make it a green. So 0.0, 1.0, 0.0, and 1.0. All right, so now that we have our fragment shaders, we can, or our vertex and fragment shader files, we can actually load them into the shader. So we're going to say, for the vertex shader, we're going to say assets/instanced/box.vs, and then for the fragment shader, it's just going to be assets/instanced/box.fs. And then we're actually going to get our box model. So we're going to include graphics/model/box.hpp, and then we're going to make this a global variable so we can control how many boxes there are with an input with a key press. So we're going to say above the main method, we're going to declare box b box as a global variable. And then let's go ahead and actually tell OpenGL how to render this. So we have to say b.init or box.init, like that. And then in the why are you barking? Oh God. In the main render loop, we're going to say we can put this at the bottom because it's the last thing that we want to do, just render the boxes. So we're going to render boxes. So we're going to say if b.offsets or box.offsets.size is greater than 0, so if offsets exist, so instances exist, we're going to say box shader dot activate, and then box shader dot set mat for view box shader dot set mat for projection, and then box dot render with the box shader. And we don't have to do any stupid lighting because it's just, if we just want to render the outline and just make it green. And then at the end, we want to clean it up. So box.cleanup at the end with the other cleanup. And then now let's assign a key to do this. So in process input, let's say if keyboard key went down, GLFW key, let's say I for insert. I'm just cool like that. We're gonna say we're gonna push back an offset and a size. So let's say box.offsets.pushback, and we're gonna push back a GLM-vec3, and let's actually customize this a bit. So we're gonna say box.offsets.size times 1.0f. So this should be increasing. The position should be increasing in all three directions. And then likewise, we're going to do the same for the size. So b.sizes, or box.sizes.pushback, and we're going to say glm-vec3, and we're going to say box.sizes.size times 0.5f. And now let's go ahead and run this. Hopefully it works after... Oh, of course it's not running. Oh, I said true E. Great. Alright, now let's try. Okay. So lights are good. That's the launch objects are so good. So I'm going to press I. And the first one we should not be getting because size is 0. I almost shit my pants doing that. Let's just load it up with a bunch of objects. Or, oh, where did it go? There it is. With a bunch of things. Look at that. Oh god, I keep losing it. So yeah, we're essentially just adding new instances. Why is it 89? Oh Jesus, this looks weird. Let's try, let's try and line it up from the end. Hold on. Hold on, let's look at this. This is, I don't know if, I honestly don't know if any of these videos are like friendly to people who have epilepsy. Like this shit's just, or, I mean honestly, if you're just like doped up on like meth or like some hallucinogenic drug, don't watch this video because this looks like fucking Spider-Man if he was in Minecraft. Like this is just weird as shit. But yeah, that's pretty cool, right? And essentially, once again, all we're doing is we're just adding new instances. So pretty cool. I think that's all the code I wanted to write, and yeah, it is. But in the next video, which will either be Thursday or what did I say? It's either Thursday or tomorrow or Thursday. I believe Thursday because I have to work on a couple of things. We're going to actually learn about bounding boxes and how to bound a box around an element or a mesh or an object, and then after that we're actually going to be getting into some hot algorithms. We're going to be making an awk tree, and from that we're going to be doing collision detection. So there's a lot of exciting stuff. So be prepared. But I've got nothing else. That's pretty much about it. I will see you guys whenever. Bye.